I'm going to solve the first quiz of electricity and magnetism that says like so. Two spheres, each of mass m. So here we have two spheres of mass m. The mass is equal to 2.33 grams. Are attached by pieces of string of length L. This is the string. That L it's equal to 45 centimeters. To a common point. So here is a common point. The string initially hangs straight down with the spheres just touching each other. An equal amount of charge Q is placed on each sphere, and then the resulting force of the sphere causes each string to hang at an angle of 10 degrees. So here omega is equal to 10 degrees. So the spheres are separating because of a charge Q. Okay, from the vertical, determine Q, that it's the amount of charge on each sphere. So here we have that this sphere has a charge Q and this other sphere has a charge Q. We're gonna work only with one side for doing it easily. Besides this charge Q, as they are repelling, we have here that there is a force, a charge force, okay? But not only that, we also have here that this sphere is causing other force, that is the force of the mass. And we also have the force of the string, that here we have as the tension. Now we know that we have these three forces. For solving this problem, we have to know that the sum of the forces has to be equal to 0 in both of the axes, in x-axis and in y-axis. So for solving this, we have to determine all the forces in x and all the forces in y. We have here this force in x and this force in y, but we have this one with an angle, so we have to determine the components in y and the components in x. So I'm gonna draw it here. We have here the tension, and we have to draw here the tension in y, and here the tension in x. Okay? For doing this, we have that this part here, it's omega, because this one is omega. So if we draw here a line, it will be exactly the same angle. So omega, here it is. So for the y, we have that it's the adjacent caret. So we will use the function cosine of theta times the tension. And here for the x-axis, we can have that this one is this one, the same that goes in here, and it's the opposite caret. So we will have that it's t times the sine of omega theta. Okay. Now, once we have determined these two components, we can find that for the x forces, we have the force of the charge, that it's equal to the force in here, the tension times the sine of theta. So we have done it at the equilibrium. Now we can determine that it's 0. For y, we have that it's the t, the tension times the cosine of theta, this one, that it's equal to the one that goes downwards. And this one is the mass times the gravity. For this one, the force of the charge, we know that we have the constant of Coulomb times the charge 1, that is this one, times the charge 2, that it's the same charge. So this will be equal to the charge square, and this one over the distance from both spheres at square, but we only are using one of the squares, so we are one of the parts, so we have that the distance is half. Okay, so for determine exactly the value of the here of the distance, we know that this part, it's the opposite caret for the angle, and the length, that is this one, it's the hypotenuse, but we don't have this part, so we are using the same function because we have the opposite value. So we're gonna say that the sine of theta is equal to the opposite cathet over the hypotenuse. Okay, but we have to know the value of r, so we calculate here the value of r, and this r over 2, it's equal to L sine theta. Then we pass the 2 here, and we have now the value of 2. So we only make it square, and now we have the result for this one. So once we have all the complete variables, we can rewrite our function. So for the x-axis, we have the constant times the charge square over L sine theta 2, and all of this to the square because of the formula in here. Now we have complete this part, that it's equal to the tension times the sine of theta, and we have here the tension cosine theta, this one, that it's equal to mass times gravity. For solving this equation, we can have a lot of methods, but I'm going to use one in which we compare it. So we can use it as a division, and here we have that the tension goes with the tension, and we have that sine over cosine is equal to the tangent. So this will be equal to the tangent of theta for this part, that it's equal to all this stays the same, but I'm going to rearrange them. The constant times the charge over the meter per gravity 2 times the L sine cos of theta to the square. So this part is exactly the same as this part. Okay, now we have this, but we want to know the quantitude of the charge Q. So for solving this one, we can pass the Q over here and all this part over here. So we will have that the Q will be equal to 2 times L sine of theta, but the square is over because we have it here and we cross it. And this part it goes with square root because of the square of the charge of mg mass times gravity times the tangent of theta over the constant, that it's exactly this part and this part. Okay, once we have this, we can substitute the length, that is 45 centimeters, theta, that is 10 degrees, the mass, that is 2.33 grams, the gravity, that is 9.81, the theta, and the constant, we know that it's 9 times 10 to the 9. Okay, then as we substitute our values and we calculate, we will obtain that the value of the charge is equal to 1.0464 times 10 to the minus 7 coulombs, that it is the same as saying that it's equal to 0.105 microcoulombs. And this is the answer for the first quiz.